Okay, we're going to continue our talk about the Doctor Who, Rose Tyler versus the Doctor. Okay, we looked at tables just a few minutes ago, kind of made a hot mess on my paper, but now I want to take kind of the same idea and apply it to the graphs. If you flip over your paper, you will have the graphs. One thing when we look at Rose Tyler, remember we called this one proportional. One reason I know it is proportional, it starts at 0. Right here is its starting point. That means I could take any time, like I could start right here and go to here, and I would say she can go 12 feet. Notice we counted, we talked about this earlier, 2, 4, 6, 8, 10, 12. 12 feet in 2 seconds. She was traveling at a rate of 6 feet per second. I could pick a different set. I could go way up here and can look at that point. I can see that at 20 to 24 feet in 4 seconds. She still would be traveling 6 feet per second. For this, when you start at 0 and it's proportional, you can take the distance divided by the time to get the speed or rate of change. All right, I will give you a second to get caught up with that. So again, when we start at 0, when the line starts right at 0, you could pick any point on this and do the distance traveled divided by the time, and you should get the same speed or rate of change. And it would be a constant rate of change. Remember, we talked about a nice straight line. But when I look at the doctor's information, right here is his starting point. He started 20 feet away from the TARDIS. So his starting point is at 20, not at the 0. Right here would be next to the TARDIS. He started at 20. Well, that just means I couldn't take this, like we did with Rose, and do 2, 4, 6, 8. That's 28 divided by 2 and get 14. And then go over here and do the same thing. I would have 32 divided by 3 and get 10.7 again. I'm not getting the same answer. Instead, because the doctor was non-proportional, big words meaning didn't start at 0, I need to just look at the difference between the points. So I'll connect these two to here to 4, traveled 4 feet in 1 second. So here we had 4 feet in 1 second. So the speed would be 4 feet per second. I could pick a different set of points. You just connect them using a right triangle. So I'm going to connect these two. I'm going to try to make my lines a little thicker so you can see what I'm doing. You may draw your triangle above or below the line. I'm just trying to see. Well, during this amount, it was 2, 4, 6, 8 feet. This is 8 feet because we have to count by 2 over a time change of 0 to 2 seconds. Oh, yes, now I can see it's 4 feet per second. When you have a non-proportional situation, meaning they did not start at 0, you need to connect any 2 points. How did the distance change over the time? How far did they travel over how long? Because of the head start. So to find this, we have to do the change in distance over the change in time. Not just reading the graph and doing distance over time. What we need to do when we have something does not start at 0, we have to work with the change. How long does it take to go that far? Okay, now we're just going to summarize some of the things we talked about. When we compare a proportional Rose-Tyler type of graph to the doctor non-proportional, what do we see? So on this side, we're going to write some notes for proportional. And then on this side, we'll make some notes for non-proportional. I'm just going to sit for a second. I'll give you about 10 seconds or so to get caught up with you to get caught up with your notes to make them look like mine. Again, you can always rewind it, pause it when you need it. Okay, straight line. Yes, both of these, when placed on a graph, make a perfectly nice straight line. Do they each have a constant rate of change? Yeah. Rose was traveling at 6 feet per second, no matter where you looked on your graph. The doctor was traveling 4 feet per second, no matter where you looked on your graph, if you connected the good points there. Uh-oh. Do they start at 0, the origin? Yes, if it's a proportional relationship. No, if it is not a proportional, known as a non-proportional. Here is really the biggest difference. How to calculate the rate of change. Simply on this one, you will find the distance divided by the time. And I'm going to change my color for emphasis for any point on the graph. For the next box, I have a little bit more to write, so I'm not going to write as big. How do I calculate the rate of change in a non-proportional situation? It is the change in distance over the change in time. It isn't just looking at the x and the y here and picking the numbers and dividing. This one is between any 2 points. not just one point. You have to find the difference between the 2 points. Like we did here and here. We found the difference in distance here and the difference in time here. Up here, I just went, oh, from here to here and divided. Oh, here to here and divided. I'll move my paper back up so you can see. If you need to, pause the video, finish copying this down,